Hello and welcome. I am back in Harry Gross's Excelopolis yet again because I am, I guess, a glutton for punishment. So yesterday was my disaster fail against Alice. Turned out part of that was harder than intended in a couple of ways. My fault because I had pulled the latest version of the game from GitHub, but I had not reinstalled it. So it was somehow on a mix of like new files and old game, which meant two things. One, the fact that the modifiers stayed on after I left Alice behind and it kept flipping me around while I was battling Giles, was not intentional, but so that's been fixed. That also meant that when I went back to Alice, it triggered a new set of modifiers, but still had the old ones on, so I was getting double on my second solve and triple on my third solve, which was wonderful, thanks Harry, but a little more than intended. But also the timing, it booted me out with what looked like 7 minutes to go. That's because Harry had changed the time from 23 minutes to 30 minutes, but because I had downloaded the file, it changed the bit where it showed how much time you had left, but because I hadn't reinstalled it, hadn't changed the bit where it actually figured out how much time you had left, so that's why it was booting me out. It's also why I got a smaller grid than what you're going to see today, because there's now a bigger grid. So I'm kind of assuming that you've seen my go at this yesterday, but if you haven't, brief explanation. We've got this ice cavern situation going on here. And the ice cavern is mostly filled with ice, which I'm actually going to delete because the ice is effectively empty. And then also filled with rocks and a little bit of snow. And so the idea is that if you slide along the ice, you'll go until you hit a rock, in which case you'll stop in front of it, or until you hit a piece of snow, in which case you'll stop on it. And then there's two other things in the grid, which is an X where you start, and a Y where you end. The aim is to get from X to Y as efficiently as possible by bouncing around various different ways until you get over here. Okay, so we've now got a 60 by 80 grid. So the first thing I'm going to do, same as before, is just number it 60, 100, 100. I would just add these together, but I can't because there's no arithmetic allowed in this modified game. So I'm just going to copy that across. So I've got 100, 200, 300 and so on. And then I'm going to add sequence, comma, 80. And I will just paste special, add values to that. So now I've got my usual address referencing. Then I need to figure out which of these are places that I can end up. And the idea is, if you're out in the middle of nowhere, there's no way to start. So you'll start at X and push off. And then forever after that, you'll always end either on a piece of snow or in front of a rock. And therefore, anything that isn't either of those, you just can't get to. So, just going to leave a placeholder for that, and just also want to record my start location and my target location. So my target location is the Y, and that is 6059. And my start is the X. Oh, sorry, lots of X's down there. Just want one up here. So that is 8 up from the bottom. 7, 8. So that is 5320. Okay, and now that I've done that, I'm actually going to change the Y to an S, just because it simplifies the logic a bit, because S is a place that you slide to and stop, and so then I don't have to have a separate logic. The other thing to note is that there is always, if you look around the edges, there's always rock at the end of every slide, except possibly this one, so that's just a thing to watch out for. Okay, so now, where are the places you can get to? We're going to say if this equals R, then false, you can't stand on a rock. Then we're going to say if B2 is not equal to blank, in other words, if it's anything other than empty ice, then true, you can stand there. And if it's empty ice, then it's going to be accessible if one of the four things around it is a rock. This equals, and this equals. Oh, what? Must be something not allowed. That's annoying. Let's say if this equals R, then false, otherwise X. It's okay with that. Just copy that down so I have a backup. Then let's say if Oh yeah, I must use not equal to, because you're not allowed greater than or less than. So we'll just say if this equals blank, then I want or, all that stuff that I'll fill in, otherwise you can't stand on it. So then my ors are this equals r, this equals r, this equals r, and this equals r. Okay, so these are the places that I can go, and let's just, oh, I was about to put a minus minus in front of it, but I can't, so never mind, forget I said that. Actually, I can basically, I can just say if that, then 1, otherwise, no, never mind, I don't care. What? Okay, so onward. So now I want to get the list of all the places that I can go from, and then I want to figure out where I can get to from those. So I'm going to say to call if. So if this, then that's a valid place, in which case give me this number. Otherwise give me, I'd usually do 1 over 0, but I'll just say d for an undefined variable, which will throw an error. And then to call with 3 will ignore that error. And these are all the places, 958 locations that I can start from. I'm just going to copy value paste that. Then directions we can go from there, we can go 100, which is add a row number. We can go minus 100, which is subtract a row number. We can go 1, and we can go minus 1, and just because we need to give our answer in north, south, east, and west, adding a row will be north. Center this so I can see better. Minus 100 will be south, adding 1 will be east, and subtracting 1 will be west. So first we'll do minus, we'll do 100. Oops. And we'll do minus 100. Then we'll do 1. And then we'll do minus 1. Okay, so from 202, what are the places I can get to? Well, the most steps you can ever take is 80, because that's the size of the thing. So let's go from there in that direction. Whoops, sorry. There we go. So from 202 in steps of 100. Now the first thing I want to do is figure out where do I hit a rock to get to the end of that. So let's do that. We'll say let A, our initial list of locations, be that. Then rock. Rock will be countifs, where this big blob is rock and this is A. Yeah. Okay, so then we can see not rock, not rock, not rock, not rock, and after whatever that is, 16 moves, it hits a rock. And like I said, there is that one place where it can come out without hitting a rock, so I'm just going to destack this with a 1 to make sure that it doesn't throw an error when I match 1 against it. No, I don't want your corrections. What's going on here? Oh, I missed the comma. Right. So then we're going to, I want to see if there's a rock in the 16th position, then I want to take the first 15 positions. So we're going to take from A by match 1 against rock 0, and I need to subtract 1 from that, but I'm not allowed to use anything. I'm not allowed to use arithmetic operations, so we'll do it that way. So these are the places that you can get to before hitting a rock. Also have to consider the possibility that you'll hit snow along the way. So snow can be, sorry, I'll just copy this, because it's basically the same. But instead of matching R, we're matching S, and instead of matching A, we're matching B. That's snow. Probably means I missed a comma somewhere. Rock, is that? Yes. Oh, sorry, I didn't define this. Whoops. So then none of those are snow, so that's fine. Oh, the other thing is, if we're standing on snow, we don't want to stop at the snow. So I'm going to say if sequence rows of B equals 1, then 0. Otherwise, I want that thing. And then, then I want to say if max of snow equals 0, then B, otherwise take from B match 1 against snow 0. So these are then the places that you can get to before either landing on snow or in front of a rock. And then I just want the last one of those because that's where you'll stop. So I say take from this, and I want to say -1, except I can't say -1, so I'll say im sub from 0 take away 1. Okay, so that is where everything gets to. It'll take a second to calculate because the countifs approach is not super efficient, but it's the easier one to do without arithmetic operations. All right, so now I've basically got what I need. So I want to start from 5320, and then I want to figure out, basically I'm going to put 5320 here, I'm going to put where I can get to from there here, and then where I can get to from there here, and work across. And at each step I'm going to have a column of all the locations I can get to, but because I'm going to be text joining and text splitting, they're going to be in text, so just to keep it consistent, I'm going to have an array of text of the start location, which is 5320, close array. Then, so because there will later be a row of these, I'm going to say by row of this hash lambda row, and then for each one I want to say if the from location converted to text is equal to at row, just because by row feeds things in as an array, so I just want to be careful by using at, then give me where we get to, otherwise give me something undefined, and then we can call acts basically like a filter to drop the errors and get just the places that we can get to from there. But now by row can only return one value, so we'll text join with a comma to get that, and then we'll end up with a row of things this way. So we'll text join the whole row, and then we'll text split that into a column of values. We'll take unique of that. And now what you can see here is we're mostly ending up back where we started, 5320 or somewhere else. So that's because from here, if you go left or right or down, you immediately hit a rock, so there's nowhere to go. And if you go up, then you end up here. So I don't want to keep, if I keep that 5320 there, then there'll be 3420 in the next column, and it'll just keep exponentially increasing the number of things I have to keep track of. So I want to get rid of that, and I'm going to do that by stacking this with everywhere that I've been so far, and then I'm going to take unique values, the ones that occur only once. So I'll say to-call of this, let's just say down as far as 500. I don't know exactly how big it'll get, probably not that big, but it's fine. Then we'll lock that, and then I want to take unique the values that occur exactly once. Okay. Oops. But he's flipping around. Okay, so this seems promising. Oops, wrong way. Don't remember exactly how far we have to go, and we'll get calc intense along the way. Alright, so let's just check here. We'll say countifs. This hash is my target converted to text. Just left to right reversal. I don't love it. Never mind. Wait, so yeah, no problem. So we run out of space. Oh, I didn't lock. Whoops. Okay, so now we're back going left to right. Yes, so we've got a 1 there. That gets to 6059 after 97 steps. Not simple. Okay, so now we have to figure out the actual route taken, because here we're just saying, after 5 moves, we could be in any of these many positions. That's not what we want, so I want to figure out from here which one of these 3 got me to 6059. And the way I'm going to do that is just pull this back in a little. I'm going to do a combined from to. Oops. text. Actually, let's just put a pipe in the middle, just to be safe. It could be something ambiguous. Probably not, but just to be safe. Okay, so then, what do I want to say? I want to say, so let's do match this and pipe and these against this. Wait, what? That shouldn't be right. Oh, sorry, other way around. Oh, no. That still shouldn't be right. A little confused now, but okay. I want to get to that from those. You're saying all of those are possible. That does not seem right to me. What? Stop flipping around. Oh, sorry. Wait, did I not? See, I'm so used to using Xmatch. Oh, what? Oh, sorry, here it is. Yes, I'm so used to using Xmatch that I forget you need to use 0. There we go. Okay. So now we're going to say if this, then give me this. And that should give me errors and the one from which I can get to where I'm going. And then if I wrap that into call 3, then this is what gets me there. And hopefully I can go all the way back in exactly that manner, and the path is unique and we're all happy. Okay. So then we just need that to point to there. And now I need to say to get from here to here. X lookup, right? Yes, I started with that. Never lost it. Okay, you can't lose the ones you start with. Okay, so look up in there, returning from the direction. Okay, and then I want to look up again to turn that into north, south, east, or west. South? Really? Oh, sorry. Yeah, no. When you go minus 100, you're increasing the rotation to the north. I was thinking the only way out of the starting point is to go up. So yeah, that should be north, this should be south. Whee! Okay, so then I think this is the answer. The answer format we're asked for is the sequence of moves that gets her there. So, oops, oh god, please, no. Don't be broken, you cannot be broken now. Oh, phew. Whee! It has broken on me once or twice while I've been doing this. Which, well... Alright, so, moment of truth. Ugh, unselect. Yes! And look at that, for my troubles I get, I am... Oh, Harry, you do have a sense of humor. Alright, so, now the next challenge from there is Lana Banana. But I am not going to do that just now because I don't have enough time. That's, I think, a 45-minute challenge. But that is the next one I'm going to try. Anyway, that's all I've got for today. I just wanted to redeem myself with Alice. Thanks for watching. See you next time.